So how is it that we secure our network? Unfortunately, there is no definite solution. And the only solution is to protect at every single level that we can. If we refer back to the OSI model, we'll see that if we want to preserve data, then we must protect at all the layers. The best way we'll find is to encrypt the data as quickly as we can. Once the data is encrypted, it is extremely difficult to decrypt it and find the information, even if the external intruder can break into any of the layers of the OSI model. At the very lowest layer, we have the physical layer. And at the physical layer, it is probably the one that needs to be protected the most. You have no protection at all, no security protection, if someone can gain access to a router and shut it down. You have no protection at all if someone can get access to a web server and take the disk out. So the physical protection of a network is probably one of the most important and the most fundamental. For this, we must keep all our equipment that we need to keep secure under padlock and within areas that people cannot get into. The other problem that we have at the physical layer is that copper cables give off electromagnetic signals. It is well known that if someone was to wrap a piece of wire around a cable, the electromagnetic information which is leaked out the cable can be easily picked up by a system. This can also go for the radiation from CRTs. It is well known that detectors can be sited even at some way away from the monitor and can actually detect the contents of the screen. So it is important, if data is to be left secure, that the information and the data channels are shielded against information being leaked out. With copper cables, it is always going to exist that some information will get out. If the cables themselves are shielded, then the information that leaks out is minimized, but it can still be detected with very sophisticated equipment. So in a highly secure environment, it is important to use fiber cables. With fiber cables, we use light to propagate along a fiber core. The light itself bounces along the cable and never radiates out with it. So it is impossible to detect the light pulses as they pass through the cable. The only way that it is possible is for the intruder to saw through the cable, which could be over 100 cores, and then to glue all the cores back again, while at the same time making a tap-off for their own communications. It would be almost impossible for this not to be protected. So wherever secure data is required, fiber cables must be used. The next layer is the data link layer. At this layer, we actually create the local area network. So this layer can, on the internet, be any networking technology such as Ethernet, FDDI, ATM, ISDN, or even a modem connection. So it is impossible to apply a different security strategy for every different networking technique. One of the most common techniques is to use a virtual LAN or a VLAN. And VLANs are built using switches. With a VLAN, networking devices connect into the switch, and we can design our network in an open plan way. Through software, we can actually define which computers connect onto which network. So if we had a switch that had 8 ports, then we could say that node 1 to node 4 connected to one virtual LAN, and node 5 to node 8 connects to another one. And then with the switch, we can say that the two networks are not allowed to communicate with each other. and can only communicate via a router, whereas we'll find out we can design a firewall for our security. The other advantage that a switch has is that it creates a point-to-point connection. Thus, it is not possible if node 1 talks to node 2 that node 3 and node 4 can listen to the communication. So even if someone connected onto our network and connected into the switch onto the correct virtual LAN, they could not listen to the conversation. This, of course, differs from the traditional Ethernet, which will typically broadcast onto a segment, network segment. Anyone who listens to the communications on the segment can read the data on the segment. Certain types of systems have built-in security. In the next module, we will discuss wireless networks. It is obviously important that security is built into wireless networks. And for this, in the most common wireless network, which is IEEE 802.11b, we have the concept of the WEP key. And the WEP key is used to encrypt data that is sent by a wireless device. Only two devices that make up a network, only they can decrypt the information sent. At the layer above that, we have the network layer. At the network layer, we're interested in network addressing and also routing. At the network layer, we can have devices called firewalls, which, as we'll see, are able to route data, able to filter data in terms of the source or destination IP address. We can also have the new devices called NAT. And NAT stands for Network Address Translation. Network address translation, as we found out in a previous module, allows the infrastructure of a network to be hidden, so that the source IP address can be hidden from the destination. Another problem that we have at the network layer is that routers continually send out their complete routing table to all the neighbors. If we have an organization which does not want anyone from outside our organization knowing the structure of our network, we must stop the router at the gateway of the network transmitting these routing tables. In a previous research exercise, I asked to define the difference between an interior routing protocol and an exterior routing protocol. The basic difference is that an interior routing protocol runs inside the boundaries of an organization. And this type of routing protocol transmits the complete contents of the whole network to all the routers inside that organization. This is, of course, not good from a security point of view if the router on the boundary of the network was to transmit it out with there, and anyone could find out the routing information for the whole network. So typically at the gateway of our network, we have a router which doesn't transmit into the external internet. So we have the concept of, outside these systems, of exterior routing protocols. And it's up to these exterior routing protocols to take data packets from one network, one organizational network, and put it into another one. Above that, we have the transport layer, which is responsible for taking data and segmenting it into data segments. At this layer, we have the concept of secure socket layers. Secure socket layer will encrypt data. It will encrypt data that is destined for a socket. We also have the concept of proxy servers at this layer, and we'll discuss that later. At the session layer, we have typically protocols such as FTP, Telnet, HTTP, and so on. Unfortunately, these protocols are extremely insecure or unsecure. For example, Telnet will send the user ID and password in a plain text format, so anyone who can view the data packets as they transverse over the internet can actually view the password and user ID. So we have secure protocols such as SHTTP and SFTP and so on. And these protocols use encryption to encrypt the messages that are sent between two session layer devices. Above that, we have the presentation layer. The presentation layer is responsible for the way that the data is viewed or the format that is viewed in. For example, GIF and JPEG and AVI are presentation standards. If we wanted to make the data more secure, then we must build in some form of encryption. And encryption is the most secure way that we can protect our data. Typical encryption techniques are RSA, DES, and PGP encryption. As much as possible, we want to secure the data as early as we can. The higher up the OSI model that we secure the data, the better it will be for securing the system. Because if we encrypt the data at the presentation layer, then it doesn't matter if someone can read our data packets or someone can view the data at the data link layer. The data is encrypted, so it can't be read. What must be noted, though, is that there may be some information at some of the layers which can be used by an intrusion device. For example, the data could be encrypted, but at the network layer, we could find out where the data came from. So if we do not hide that information, then the network becomes less secure. So information can be gleaned at each of the layers.